power of 1 minus n. So if n is 2, we would have v equals y raised to the power of 1 minus 2, or y to the negative 1, which is the same as 1 over y. Notice that v and y are reciprocals, and since we have to perform a substitution in the differential equation for both y here and here,
Then, so here v is different. So it's all the equation is the same as the how is it called? Where's the other one? Oh, solving the equations through the differential equation through the integrating factor, except that it has a y to the n power. So then the n power is important here. So like after there's a formula, so v equal to y to the 1 minus n, which is what I'm not using practice, but it's basically saying that v is going to be equal to y 1 minus 2, right? It's going to be y minus 1. Let's see
as
how it
well as
goes.
y prime.
Oh, it is. Let's go 1 over y prime.
Prime, we actually want to solve this equation for y. Again, since they're reciprocals, we can say that y is equal to 1 over v, or v to the negative 1.
Okay, so he wants to replace all the y's. So he got v equals 1 over y. And instead of putting y, he says, he gets the y, so it's going to be 1 over v equal to y. And so here instead of,
So again, we know y equals v to the negative 1. And now we also have to determine y prime, which is actually dy dx, not dy dv. So we'll have to perform implicit differentiation here. So y prime is going to be equal to negative 1 times v to the negative 2, or negative v to the negative 2 times dv dx. Again, we're applying the chain rule here because we want the derivative in terms of x, not just v. And now we'll go ahead and perform this.
so he integrates. He says,
Substitution.
I don't get
So
it.
y prime or dy dx is going to be all of this, v.
So let me see. He has v to the minus 1. So y equals v to the minus 1, right? So to get the y prime is to basically says integrate. It's a weird one. Integrate v minus 1. If I integrate, I get the same thing, guys. Just minus 2. And then minus. Oh, no, hold on. This is not it. Then he did something else.
And now look at dx. 2 or negative v is going to be equal to, we'll have to perform implicit differentiation here.
Implicit differentiation, I don't know that one. Because I know that one. Just duplicate
Welcome to a lesson on Bernoulli.
implicit differentiation. Nice. This is differentiation.
Welcome to implicit differentiation. The goals of this video are to differentiate implicitly and also implicit function inside of the equation, so we'll subtract 4x on both sides. First step, we need to find dy dx. 4 times y dx, an expression involves plate or inside. So step 1 is to differentiate both sides of the equation with respects to x. So if the term involves x, we'll differentiate as we normally have a factor of dy dx. So dy dx. And again, we're just thinking of y as some function of x, and we're applying the chain rule. Equals 0. So we'll isolate this term on one side, so we'll subtract 4x on both sides. So we'll apply the chain rule. And again, y squared times dy dx. And again, we're just thinking of y as some function of x, and we're applying the chain rule. Equals 0. So we'll isolate this term on one side, so we'll subtract 4x on both
Oh, I
sides.
see. It takes the derivative of x, but when he goes to the y, then he takes the derivative of y as if it's x, but he adds dy or dx to tell that. So here, what would it be? Let's see, of b. What was his result again? Okay, I think I messed that up.
Welcome to a lesson n. So if n here and here, so again, we'll have to perform implicit times because we want the derivative in terms
dv over dx. So dv over dx. Can I get the dv over dx now? Guess he's taking the dy, right? Yes. But that's gonna be the integral. If it's the integral minus 2, that that's gonna be over 2.
of x equals x dv dx.
I still don't get it. What's the difference? Implicit differentiation calculator. E to the minus 1 equal to 0. Alright. V equals 0. Oh, there you go. Now is it the same rule? So implicit differentiation. Maybe you made a mistake.
Again, we're applying the chain rule here because we want the derivative in terms of x.
Of x to the minus 1.
X, not just v.
Maybe someone in the comments posted something. Oh, I have no idea how to do this shit. How did he get minus v? Minus b
And now
squared.
we'll go ahead to x2, or negative v to the negative equal to negative 1 times v to the negative 2, or negative
Negative 1 times b to the negative 2.
v to the negative 2 times dv dx. Again, we're applying the chain rule here because we want the derivative in terms of x, not just v. And now we'll go ahead and perform the substitutes. Watts equation.
Oh
So y
gosh. This is so confusing. It's an implicit differentiation, so it should be minus v. Oh, minus 2 try. Is right. Oh my god, oh my god, so dumb. I spent so much time trying to get there. But at least I got it. Alright, so it's gonna be y equal v minus 1 minus 1. No, mine. No, y minus v. So minus 1 is just gonna be minus v minus 2. Finally got it. Okay. So now I substitute. Instead of y prime, I will put it minus v, then minus 2, then plus x. Hold on. So EY in term of x, so that will be dv over dx, and then so it's gonna be minus v minus 2 dv over dx plus x. Y is gonna be x times 1 over v equals x times y squared. So times y is gonna be 1 over v, and then square. That's gonna be equal to minus, I don't know if we
prime
change it when we put in.
thing by factor, which will
Oh, he divided us. Interesting. Yeah, he wanted to get out rid of the dv, so but he did dv to the positive 2. They did dv minus negative 2. Right. Alright, let me check that. That's gonna be minus b squared dv over dx plus x over v equals x over v squared. So to get rid of that one, just to leave it as an expression of dv over dx, it says this is gonna divide by minus v just to get out of the negative sign, and oh, it is minus 2, and then here so it's gonna be minus 2 minus, it's gonna be minus 2 minus minus 2, so you get minus 2 plus 2 0. It's supposed to be minus 2, and then see, It's gonna be give. So it's gonna cancel this one out. It's gonna be dv over dx plus, so x v over v, so x over v times minus v to the minus 2 over 1, because they flip. Alright, so the 1 is going to be on top. Yeah, the 1 is going to be on top, not at the bottom. The 1 is going to be on top. 1, not 1, but minus 1 over v minus 2. And then this is going to be equal to x v squared times minus 1 over v minus 2. It's going to be dv over dx. But not plus, but minus actually. Minus x over, oh, and I'm gonna add this variable. It's gonna be 1 minus 2. It's gonna be minus 1. So it's supposed to be v. Okay. Did I make a mistake? Oh, this is gonna be v. Okay. And then it's gonna be equal to okay, it's gonna be 0, cancel out. 2 plus minus 2 is gonna be 0. And then this is gonna be minus x. So this is, oh, now it's easier to do it, because I can do it through the integrating factor, which is gonna be so I of x is gonna be equal to e to the integrating factor, to the integral of minus x dx, I guess, and then it's gonna be equal to e to the integrating to the minus 1 to the minus 1 times the integrating factor of x, which is gonna be x is gonna be x squared over 2. Yeah, so it's gonna be minus x squared over 2, and then that's gonna be y is gonna be equal to 1 over e to the minus x squared over 2. And then times integral of e to the minus x squared over 2 times minus x. That's, oh shit. So this shit seems a bit too complicated. dx. What the fuck?
Multiply both sides.
I get this.
Apply the differential in here. Now let's go ahead and distribute side, not v. So let's finish this on the next slide.
Times v. Right?
E raised to the power of the integral of p of x integrated with respect to x. So in this case, p of x is going to be just negative x. So the integrating factor, mu of x, is going to be equal to e raised to the power of the integral of negative x dx. So mu of x, or this should be of this differential equation
Exactly.
by the integrating
Wait, what?
factor. Let's go ahead and do that on the next slide. By the integrating factor. Multiply both sides of this differential equation raised to the equation negative 1 minus on the right side. Now that multiplies them. So the integrating factor mu of x is going to be equal to e.
Wait, hold on. Don't tell me I ain't. Oh, I did good.
Raised to the power of the integral of negative x dx. So mu of x by the integrating factor by 2. Now we'll multiply both sides of this differential equation by the integrating factor. Let's go ahead and do that on the next slide.
Wait, what?
Now let's go ahead and distribute.
I feel like I missed something.
Divided by 2. Now we'll multiply both
Is it minus x?
sides of this divide. Now let's go ahead and distribute.
Maybe I was doing it wrong all this time. So I have dv over dx minus xv. It's going to be equal times e to the minus x squared 2. Then it's going to be equal to the other side is going to be minus x times e to the minus x squared over 2.
Distribute.
Let's see what he gets. Let's try to solve it. What I mean, so this is gonna be e to the minus x squared over 2 dv over dx minus e to the minus x squared over 2 xv equals to minus x 8. Well, actually, I'm gonna put it minus v to the minus x over 2 x
For integrating factor in y, or in this case v. So this is equal to the derivative of e raised to the power of negative x squared divided by 2 equal to the derivative of integrating factor in y. It's always going to be equal to the derivative of the product of the integrating factor in y, or in this case v. So this is equal to the derivative of e raised to the power of negative x squared divided by 2. Again, normally it's times y, but in this case it's times v. And we can easily verify this if we apply the product rule here.
I didn't get that before. Why can't I get that? Why can't I get that? So
But because it's equal to the left side, it's also equal to the right side of this equation. So we can say it's also equal to negative x e raised to the power of negative x squared divided by 2. And now if we integrate both sides of this equation with respect to x, we can then solve for v and then go back and solve for y. So now we'll integrate this with respect to
No
x.
idea what it did there.
On the left side, the integral and derivative undo each other, so we're just left with e raised to the power of negative x squared divided by 2 times v equals u sub 2 negative x.
Yeah, I got
This
lost
may look